What exactly mean by space-time theory? Hey there fellow space enthusiasts, welcome back to our channel where we talk all things space, from rocket launches to gravitational waves. Today, we're going to dive into the topic of space-time theory. You may have heard of this term being thrown around when it comes to the physics of space and time, so we're going to break it down for you and explain what exactly it means. First off, let's define spacetime. It is a concept that combines the three dimensions of space with a fourth dimension of time, into a single four-dimensional continuum. Imagine a fabric that is stretched out and held taut in all directions. This fabric is spacetime, and all the objects in the universe are placed upon it. Spacetime theory is a theory from the field of physics that aims to describe how space and time exist in our universe and also how they interact with one another. The concept is fundamental to our understanding of the physics of our universe. Albert Einstein is the father of this theory. His theory of general relativity set the foundation for much of today's research on spacetime. In his theory, Einstein proposed that space and time are not two separate entities, but instead, they are merged into a single spacetime continuum. He described spacetime as being curved by the presence of matter and energy. The more matter and energy there is in a particular area, the more curved the spacetime is in that area. One of the most important implications of spacetime theory is that it explains gravity. According to Einstein's theory, gravity is not a force, but rather it is the curvature of spacetime caused by mass and energy. The amount of curvature in a particular area determines the strength of gravity in that area. Now, let's break down how spacetime theory works. In general relativity, spacetime is represented as a fabric or a sheet with four dimensions, three dimensions of space and one of time. This fabric can be warped or curved, depending on the mass and energy of objects within it. The reason that the fabric can be warped or curved is that mass and energy in the universe exerts something called gravity. Gravity is the force that attracts two objects with mass towards each other. In our everyday lives, we might think of gravity as something that pulls us towards the Earth, or causes objects to fall when we drop them. However, according to Einstein and spacetime theory, gravity is actually the result of the curvature of spacetime. Think of it this way: when you place a heavy object on a trampoline, it creates a curvature or dip in the fabric. Other objects placed on this same trampoline will be pulled towards this dip, and this is similar to how gravity works according to spacetime theory. So, let's say you were to look at a picture of space from a distance. It would appear empty, but that's not quite accurate. All objects in space cause curvature in the fabric of spacetime, and that includes even the smallest particles in the universe. This curvature is what keeps our planets in orbit around the Sun, just like a ball rolling around the dip in the trampoline. Another implication of spacetime theory is that it predicts the existence of black holes. Black holes are a phenomenon in space where gravity becomes so strong that even light cannot escape it, making them invisible to the naked eye. The creation of black holes is directly linked to the curvature of spacetime. At the center of a black hole, there is a singularity, which is a point where the curvature of spacetime becomes infinite. This means that space and time no longer exist as we know them, and they essentially break down. This is why we cannot see black holes, because everything within its event horizon is trapped, including light. Another interesting implication of spacetime theory is that it implies time travel could be possible. The idea is that if you could warp spacetime enough, you could create a time loop, where time would seem to be moving backward or forward. However, at present, there is no theoretical or experimental proof of this. In conclusion, spacetime theory is an important concept in physics that helps us understand the fundamental workings of our universe. The concept of a four-dimensional spacetime continuum, where space and time are deeply interwoven, has a profound impact on our understanding of gravity, black holes, and even time travel. As our understanding of space continues to grow, so too will our understanding of this remarkable theory. That's it for today, folks. We hope you enjoyed learning about spacetime theory. If you have any questions or would like us to dive deeper into any of these topics, feel free to leave a comment below. And don't forget to like and subscribe for more space content. Thank you for joining. Have a great week. Thanks for watching.